Okay, then this is question 4, which is a factor theorem, remainder theorem style of question. Before we do this, I think it's helpful to review what the factor theorem and remainder theorem are. So let's have a quick look. We'll start with the remainder theorem. The remainder theorem states that if I get a remainder r when I divide a polynomial by x minus a, then if I substitute a into the polynomial, I will get remainder r. Okay, so let's just think about that a little bit more carefully. Imagine I've got a polynomial here, and I do polynomial division where I divide it by x minus a. In the end, I get a remainder r. Well, if that's the case, then we know that if I was to take a and to substitute it into the polynomial, I will get the same value as the remainder. I will get r. Okay, now let's think about the factor theorem. The factor theorem is actually a statement of the remainder theorem for a specific case. We'll think about that a bit more in a moment. But the factor theorem states that if x minus a is a factor of the polynomial p of x, then that means that x equals a is a root. Now, let's just think really, really carefully about that. If x minus a is a factor, that means that if we were to divide p of x by x minus a, we're going to get a remainder of 0. So in other words, this statement here is basically the same thing as saying that the remainder must be equal to 0. Okay, that's basically what that means. And so if we were to use the remainder theorem, then that would mean if we substituted a into our polynomial, we should get a remainder of 0, right? So if we did p of a now, then what we would get is we would get 0. But hang on, when p of a equals 0, that's the same thing as saying that a is a root, right? That is a definition of a root there, because a root is an x-intercept. It's a place where the y-coordinate is 0. It's a place where the polynomial is equal to 0. So this thing is just another way of saying that a is a root. So if x minus a is a factor, a is a root, because that's just another implication of this thing here, the remainder theorem. So in a way, what I'm trying to stress here is not only knowing the definition of remainder theorem and factor theorem, but also that these two are not separate things, right? They're not like two different theorems. Actually, the big theorem is the remainder theorem, and the factor theorem is like a specific instance of that. It's the instance where the remainder is 0. Okay, so actually I find that the textbook to be really quite irritating in this way, because what it does is it teaches you the factor theorem first, and then it teaches you the remainder theorem second, as if the remainder theorem follows on from the factor. But actually it's the other way round, isn't it, right? The big idea is remainder theorem, and the factor theorem is like the kind of the specific case of that. All right, now let's go down and let's look at the question. The polynomial x is given by this thing here, where a and b are integers. P of x has a factor of 2x plus 1, and it has a remainder of negative 6 when divided by x plus 1. We want to find the values of a and b. Okay, well, if it's got a factor of 2x plus 1, then we can set that factor equal to 0 to find out what the root is. And so that root is going to be equal to negative a half. Now, if the root is negative a half, that means that if we substitute negative a half into the polynomial, I should get 0. Okay, so let's just try that. I'm going to get a times by negative a half cubed. Well, negative a half cubed is negative an eighth, so that's negative an eighth a, plus b times by negative a half squared, which will be positive a quarter b, plus 3 times by negative a half, which is negative 3 upon 2, plus 2 is equal to 0. Now, that's all going to be quite irritating to deal with, what with all those fractions. So what we're going to do is we're going to take the entire polynomial and we're going to multiply it through by 8 to get rid of all of those fractions. So negative 1 upon 8 times by 8 is going to be negative 1, so we get negative a. A quarter times by 8 is going to give us 2, so that's 2b. Negative 3 upon 2, if I times that by 8, then it's 3 times by 4, so that's going to be negative 12. And then 2 times by 8 is 16. So we get that is equal to 0. And we'll just simplify that a little bit. We'll get negative a plus 2b is equal to negative 4, right? Because negative 12 plus 16 is positive 4, but I bring it to the other side. Right, I'm going to label this guy here equation 1, all right? Because we're going to get another equation in a moment. Okay, second statement. We are told that p of x has a remainder of negative 6 when it's divided by x plus 1. Well, if we use the remainder theorem, that tells us that if we were to substitute in negative 1 into the polynomial, we should get negative 6. Why is it negative 1? Well, if we just go back to the remainder theorem just for a second, right? it says that if we divide by x minus a, and if we substitute a in, we get r, right? So it's x minus a here. So how can we think about x plus 1? Well, we could think about x plus 1 as being x minus minus 1, right? So hence that's why we substitute in. So I'm going to do p of negative 1 is equal to negative 6. So if I do all of that, I'm going to get a times by negative 1 cubed, which is going to be negative a cubed, right? Because negative times negative is a negative. Sorry, not negative a cubed, just negative a, beg your pardon. Plus b times by negative 1 squared, so that's going to be positive b. What else was it? Plus 3 times by negative 1, so that's minus 3. And then plus 2 is going to equal to negative 6. So I think if I simplify that, I get negative a plus b is equal to, well, minus 3 plus 2 is minus 1. I add 1 to both sides, I get negative 5. And so that's going to be my equation 2, right? So I've got two equations in terms of a and b. What's the best way to deal with those? Well, I think elimination, isn't it? I'm going to do equation 1 minus equation 2. And so that means I'm going to get negative a minus minus a, that's 0. 2b minus b, that's b. And then negative 4 minus minus 5, that's plus 5. So b is going to be equal to 1. And if b is equal to 1, well, I can substitute that into here. I'm going to get negative a plus 1 is equal to negative 5. Therefore, negative a is equal to minus 6. And that means that a is equal to positive 6. Okay, I'm just going to check my answers for that against the mark scheme, make sure that I am correct. So yeah, a is 6 and b is 1 are the right answers. Okay, then let's do question 5. The polynomial p is such that p of x is equal to this thing, where a and b are constants. And we're given that x plus 3 is a factor of both p of x and p prime of x. So we want to find the values of a and b. Okay, I think we need to just recap what the factor theorem is. And the factor theorem states that if a is a root of a polynomial f of x, then x minus a is a factor of f of x. So for example, if 2 is a root, x minus 2 is a factor. If 5 is a root, x minus 5 is a factor. If negative 4 is a root, then x minus minus 4, so x plus 4 is a factor. And vice versa, right? If we know that x minus 7 is a factor, we also know that 7 is a root. So this is the key bit of knowledge here, because what we're told in the question is that x plus 3 is a factor. So what does that mean? It means that negative 3 is a root, right? Because x minus minus 3 is the factor. Okay, so what are we going to do? Well, I think probably first thing we want to do is why don't we just substitute in negative 3 into this guy here. So I'm going to do that. So we know that p of negative 3 is going to equal to 0. That's kind of the key fact. So I'm going to get 5 times by negative 3 cubed. So negative 3 cubed is going to be negative 27. Plus a times by negative 3 squared, which is 9. Plus 39 times by negative 3. So what's that? 40 times by 3 is 120. Minus 3 is 117, isn't it? Right? So minus 117 plus b is equal to 0. Okay, so I end up with that, and 5 times by 27, so 10 times by 27 is 270. Divide by 2 is 135. So minus 135 plus 9a minus 117 plus b is equal to 0, which means that 9a plus b is equal to 135 plus 117, so that's 245, 252, I think, 252. Yeah, that looks all right to me. Okay, then, so that's one equation that we get. Now, the next one we can do is we're going to differentiate our function. Oh, sorry about that. So if I do p prime of x, then what I'm going to get there is 15a, sorry, not 15a, 15x squared plus 2ax plus 39. And again, we're told that negative 3 is a root of this. So I can write that p prime of negative 3 is equal to 0. So if I substitute in -3 into there, I'm going to get 15 times by -3 squared, which is 9, plus 2 times by -3, so that's actually going to be negative 6a, plus 39 is equal to 0. You know what? I think just to make my life a little bit easier, I'm going to divide everything through by 3, right? So that's going to be 5 times by 9 minus 2a plus 13 is equal to 0. And therefore, 5 times by 9 is 45. So we've got 45 plus 13, 58 minus 2a is equal to 0. So 2a is equal to 58. So a is going to be equal to 29. Okay, and if a is equal to 29, we can substitute that into here. So we've got 9 times by 29 plus b is equal to 252. Okay, so 9 times by 29. Sorry about that. 9 times by 29 plus b is equal to 252. 252, is that right? Okay, well, 10 times by 29 is 290 minus 29 plus b is equal to 252. And so what's that going to be? 290 minus 29, so minus 30 plus 1, 261. So 261 plus b is equal to 252. So b is going to equal to -9. Sorry, guys, I didn't bring my calculator today as I was doing it, but hopefully you find it helpful as well, right? You can see how I do the mental arithmetic, because if your calculator jams in an exam, that's really annoying. But hopefully it means not everything is over. Okay, so I get that a is 29, and I get that b is -9. Okay, so this is question 2, which is a polynomial factor theorem, remainder theorem style of question. We've got a polynomial p such that p of x is equal to this thing here, and we want to find p of x in the form 2x minus 5 times by q of x plus r, where q of x is a polynomial and r is a constant. Now, the way of asking this question is somewhat unusual. It differs from the previous years in terms of the way it's been asked. But I think all it really is just a rearrangement of the thing that you're used to. So I'm going to try to explain. Imagine that we've got a polynomial, p of x, and what we do is we divide that polynomial by 2x minus 5. Okay, so we do that using the ordinary polynomial division. Then when we do that, what we get is we get another polynomial. So in this case, I'm going to call that q of x, right? So we get another polynomial q of x, and then sometimes we get a remainder left over. Now, what is that remainder? That remainder is the bit that still needs to be divided by 2x minus 5. Okay, so if you wanted an analogy, right, imagine that we did 10 divided by 3. Okay, now, if we do 10 divided by 3, the closest multiple of 3 is 9, and 9 divided by 3 is 3. But then we've got a remainder of 1, isn't it? And that 1 still needs to be divided by 3. So we write 3 plus a third, or more commonly, 3 and a third. Okay, so it's very similar to that, because what we're saying is we've got a polynomial, we divide it by 2x minus 5. Okay, we get this polynomial here, but we've got a remainder, and that remainder still needs to be divided by the 2x minus 5. Okay, now, if we were to take that line and rearrange it such that we multiply both the left and the right by 2x minus 5, what we would get is this. We would get p of x is equal to 2x minus 5 times by q of x plus r. Right? Because if you think about it, this guy, if I multiply it by 2x minus 5, I just get the remainder r there. Now, that is this thing here. Okay, so in other words, how do you find q of x? Well, q of x you get through your ordinary polynomial division. And what is r? R is going to be the remainder that is left over. Okay, so we're just going to do polynomial division. So we've got to get the polynomial 6x cubed minus 35x squared plus 34x plus 45. And we've got to divide that whole thing by 2x minus 5. All right, so we're going to do that full division there. All right,
Now, how do we do that? Firstly, we take the leading term, 6x cubed, and we divide it by 2x. If we do that, what we will get is 3x squared. So I'll write that here, 3x squared. We then take that 3x squared and we multiply it by this whole divisor. Okay, so if we do that, what we will get is we will get 6x cubed, because 3x squared times by 2x is 6x cubed, minus 15x squared. Okay, so that's that first step. Now, once we've done that, we are going to subtract this bottom line from the top. Okay, so 6x cubed minus 6x cubed is 0. Now we've got to be careful. We've got negative 35x squared minus 15x squared. So minus minus is plus 15x squared. So negative 35 plus 15 is negative 20. So this guy here is going to be negative 20x squared. And we've still got the 34x plus 45 left over. Okay, so now negative 20x squared is our new leading term. We're going to divide it by 2x. If we do that, we're going to get negative 10x. Okay, and then we take the negative 10x and we multiply it through by this divisor. So negative 10x times by 2x is negative 20x squared. Negative 10x times by negative 5 is positive 50x. And again, we're going to have to subtract the one from the other. Okay, so negative 20x squared minus 20x squared is 0. 34x minus 50x is negative 16x. And we're left here with 45. Okay, we're almost at the end. The negative 16x is our new leading term. We're going to divide it by the 2x. And if we do that, we're going to get negative 8 there. Okay, and we take the negative 8, we multiply it through by 2x minus 5, which will give us negative 16x plus 40. And so then we are going to subtract that. Negative 16x minus 16x is 0. 45 minus 40 is 5. So in other words, what we've got, if we divide our polynomial by 2x minus 5, we get this thing here, 3x squared minus 10x minus 8, with a remainder of 5. Okay, so I'm going to write that down. End result is that p of x is equal to 2x minus 5 times by, what was it? 3x squared minus 10x minus 8. 3x squared minus 10x minus 8. And then with a remainder of 5, right? So this guy is our q of x. This guy is our remainder. Okay, let's go on to part B then. Okay, part B and C. Hence, we want to write the expression p of x minus 5 as a product of linear factors. Well, hang on. If we've got p of x is this thing, then all we need to do is subtract 5 from both sides, and we'll get p of x minus 5 is just equal to 2x minus 5, 3x squared, minus 10x, minus 8, right? So that's that. But if we just read the question very carefully, it says write it down as a product of linear factors, right? Now, this guy here is a quadratic factor, so we're going to need to factorize it once more in order to make it into linear factors. Okay, so we've got 2x minus 5. All right, now then, we're going to have to factorize this. Now, we'll practice it for the guys who are going to have to sit the non-calculator paper. We're looking for two numbers, or two things that multiply together to give 3x squared. Well, there's only one way to get that. You're going to get 3x, and you're going to get x. And then what we want is we want two numbers that are going to multiply together to give negative 8. Right, so one's going to be positive, one's going to be negative. We know that for sure. And it's got to combine in such a way that we get negative 10x. Well, if I was to put a negative 4 here, and I was to put a positive 2 here, that's going to work out. Because positive 2 times by negative 4 is negative 8. And then 3x times by negative 4 is negative 12x. And then this is going to be plus 2x. So negative 12x plus 2x is negative 10x. Okay, so this guy here is p of x minus 5 written as the product of linear factors, right? So we've just done part B. Okay, so part B done. Now, what about part C? Hence, we want to write down the solutions of the equation p of x is equal to 5. Well, let's think about that. If p of x is equal to 5, then what's going to happen? Over here, we're going to get 5 minus 5, aren't we? Which is 0. So we're going to end up with 0 is equal to 2x minus 5 times by 3x plus 2 times by x minus 4. In other words, basically what we've got to do is we've got to find the roots of this particular expression here. So how's that going to work? Well, this thing will be equal to 0 only when that's equal to 0, or that's equal to 0, or that's equal to 0. So if 2x minus 5 is equal to 0, x must be equal to 5.2. If 3x plus 2 is equal to 0, that will be x is negative 2 upon 3. And if x minus 4 is equal to 0, x must be equal to 4. Okay, so that will be our answer for part C, writing down the solutions of that equation. Okay. Now, just one final thought on that, guys. It looks like it's a bit of an unusual way of asking that question, and so it may freak some of you out. But actually, just a little bit of extra working. Hopefully, you'll see. Actually, it's not too dissimilar from the questions you've done on other papers. Okay.
Okay, so here we are in question 4, which is a factor theorem, remainder theorem style of question. So we really need to know what those two theorems are. So I've started by writing out the remainder theorem for you here in blue. The remainder theorem basically states that if we divide a polynomial by x minus a and we get a remainder of r, then it means that if we substitute a into the polynomial, in other words, if we find p of a, then we will get that remainder r, right? So if I divide a polynomial by x minus a and get remainder r, then p of a is equal to r. It's best illustrated with an example. Let's say I took a polynomial and divided it by x minus 3, and I get a remainder of 7. Then what that means is if I was to substitute 3 into the polynomial, I would get 7, right? Or another example, if I was to divide my polynomial by x minus 10, and get a remainder of 4, then what that means is if I was to substitute 10 into the polynomial, I would get 4. So in this particular case, we want to find the remainder when p of x is divided by x minus 2. Well, we could do a polynomial division, but that'd be kind of crazy, right? Because it's only worth 1 mark. It's not worth all that work. So instead what we say is, okay, if we were to substitute 2 into the polynomial, then what we would get is we get our remainder. So we're going to exploit the remainder theorem here because it makes our life easier. So we're going to find p of 2. And that means we're going to get 6 times by 2 cubed. 2 cubed is 8, plus 2 squared is 4, minus 12 times by 2, which is 24, plus 5. And 6 times by 8 is 48, plus 4 minus 24 plus 5. Okay, now 48 minus 24 is 24. And 24 plus 4 is 28, and 28 plus 5 is 33, and 33 is our answer. Okay, so that's part A, that's worth 1 mark. Part B, we want to show that 2x minus 1 is a factor of p of x. Well, okay, this is using the factor theorem. Now, factor theorem is actually basically a consequence of the remainder theorem, if you really think about it, but I'll write it out here nice and simply for you. If x minus a is a factor of a polynomial, then x equals a is a root, right? So if x minus 5 is a factor, 5 is a root. If x minus 12 is a factor, then 12 is a root. If x plus 8 is a factor, then minus 8 is a root. Because if you think about it, it's x minus minus 8. It's the same thing as x plus 8. Okay, and we should probably just state what a root is for those of you who are not sure, right? If f of a is equal to 0, then a is a root of the polynomial f of x, right? So in other words, a root is an x-intercept. It's the value where the function is equal to 0, right? So if 3 is a root, it means if we were to substitute 3 into polynomial, we will get 0. If 5 is a root, it means if we substitute 5 into polynomial, we'll get 0, which is actually the same thing as the remainder theorem, right? Right? Because what we're saying is we get a remainder of 0, right? So there's no remainder when we've got a root. Therefore, what does that mean? It means that if we were to divide by x minus a, then it must be a factor,
right? So if a is a root, it means that we've got a remainder of 0, which means that x minus a divides through by the polynomial such that there is no remainder, which is the same thing as saying that, that x minus a is a factor. Okay, so let's have a look at part B here. I want to show that 2x minus 1 is a factor of p of x. Well, okay, if 2x minus 1 is a factor, that's actually the same thing as saying x minus a half is a factor, right? So I pull out the 2. And so if x minus a half is a factor, then it means, therefore, that we should expect x is equal to a half to be a root of the polynomial. And how can I show that x equals a half is a root? Well, I just got to substitute it in, right? I've got to find p of a half. So let me find out what the function was. It was 6x cubed plus x squared. Okay, so we got 6 times by a half cubed, which is an eighth, plus a half squared, which is a quarter, minus 12 times by a half. So that's going to be minus 6, isn't it? Plus 5. Well, 6 upon 8 is 3/4. 3/4 plus a quarter is 1. So we've got 1 minus 6 plus 5, and that's equal to 0. So we can write a statement like, since x equals a half is a root of the polynomial, then x minus a half is a factor. And of course, if x minus a half is a factor, it's actually the same thing as saying that 2x minus 1 is also a factor, right? Those two statements are equivalent. Okay? All right. Part 2, hence write p of x as a product of linear factors. All right, well, basically, what we've just shown is that if we've got p of x and we divide it by 2x minus 1, right? 2x minus 1 is a factor. That means that if we were to do the division, we will get some other factor, a quadratic factor as a result, with no remainder, right? With 0 remainder there. Okay, so what we're going to do is just going to do a polynomial division, basically. So if I do the polynomial division, so 6x cubed, so let's just get rid of that. 6x cubed plus x squared minus 12x plus 5. I'm going to just make sure that I've got that right. Okay, and then we're dividing this all through by 2x minus 1. Okay, so we're going to take the leading term, 6x cubed, divided by 2x, we get 3x squared. 3x squared, we're going to take the 3x squared times it by 2x minus 1. 6x cubed minus 3x squared. Okay, and then we're going to subtract, okay, the bottom from the top. So 6x cubed minus 6x cubed is 0. X squared minus 3x squared is plus 4x squared minus 12x plus 5. So 4x squared becomes the new leading term. So I do 4x squared divided by 2x, which is going to give me positive 2x. I'm going to take that 2x and multiply it by my entire divisor here. And so that's going to give me 4x squared minus 2x. And I'm going to subtract that off. So 4x squared minus 4x squared is 0. Negative 12x minus 2x is plus 2x. So that gives me minus 10x plus 5. Negative 10x becomes the new leading term. I divide it through by 2x, which is going to give me negative 5. And so if I take negative 5 and multiply through, I get negative 10x plus 5. And of course, if I subtract that off, I get 0 as I expect. Okay, so what have we shown? We have shown, therefore, that p of x can be written as 2x minus 1 times by 3x squared plus 2x minus 5. So 3x squared plus 2x minus 5. I just want to double check that. Yeah. And we were asked to write this as the product of linear factors, I think, which implies that that quadratic will factorize. So we've got 2x minus 1 bracket 3x and a 3x. Oh, sorry, not a 3x and a 3x. Sorry, a 3x and an x. And we want to choose two numbers that multiply to give negative 5. Well, it's either going to be positive 1 and negative 5 or the other way around, right? Negative 5 and positive 1. So I think that that would have to be a positive 5 here and a negative 1 there. The reason for that is if I was to multiply through, 5 times by x is 5x, 3x times by negative 1 is negative 3x. So 5x minus 3x is 2x, so that works out. Okay, so what else we required to show? No, that's it. We've written it as the product of linear factors. Okay, so I think we just got one last part. Hence, solve the equation 6 sine cubed theta is equal to, plus sine squared, blah, blah, blah. Okay, basically, if we do the substitution, x is equal to sine theta, sorry, beg your pardon. If x is equal to sine theta, then this just gives us the polynomial that we had before. Okay, so it's recognizing that this question, part 3, is connected to what goes before, and the key to that, of course, is the word hence. And we've just found out that we can write this polynomial as 2x minus 1 times by 3x plus 5 times by x minus 1, I think. Yep. And so therefore, this has got solutions of 2x minus 1 is equal to 0, which means that x is equal to a half, or x is equal to negative 5.3, or x is equal to 1. And so therefore, sine theta is equal to a half, or sine theta is equal to negative 5.3, or sine theta is equal to 1. Now, immediately we should recognize that the middle of these is not possible, right? Because negative 5.3 is a value that is not within the range of positive 1 and negative 1, right? So that guy's out. There are no solutions there. But then we want to find the other solutions, and we want to do it between 0 and 90 degrees. Okay, well, I know you guys, many of you will probably hate me for this. You hate graphs, right? Well, I just think graphs are by far the easiest way to do it. I'm really sorry. I'm going to keep telling you to do that. So this is the sine wave, right, between 0 and 180. I'll just draw the full thing. There you go, like that. All right, so that's the sine graph, 180, right, 90 degrees there. Okay, so basically we just want to find solutions in this first part. So if sine theta is equal to half, that is going to give you theta is equal to 30 degrees on your calculator. We don't need to have any other solutions because that's just that one there. And if sine theta is equal to 1, well, that's going to be theta is equal to 90 degrees. And that will be the only solution there. Let me just double check. It was less than or equal to 90. Yeah, it's less than or equal to 90. So I think we've just got two solutions there, 30 and 90 degrees. And I'm going to check the mark scheme just to make sure that that's correct. 30, 90, and you need to state that there's no value from sine theta is equal to negative 5.3, okay, which I did by crossing it out. Okay. Right, question 6, which is a factor theorem, remainder theorem style of question. Given that x minus 3 and x plus 1 are both factors of this polynomial, solve the equation, basically find the roots of the polynomial. Okay, now in order to do this, we need to know what the factor theorem is. Now I've written it here, right? This is the factor theorem. If x minus a is a factor of a polynomial, then x equals a is a root of that polynomial. Okay, so in other words, it's a solution of the polynomial. What is a root? A root is where the function is equal to 0, right? So it's where f of x is equal to 0. Okay, all right. So let's just try to elaborate this. This is saying that if x minus 2 is a factor, 2 is a root. If x minus 3 is a factor, 3 is a root. If x plus 4 is a factor, then negative 4 is a root. Why is that? Because x plus 4 is the same thing as x minus minus 4, isn't it? Right? So if x minus minus 4 is a factor, then negative 4 is a root. So let's try to apply it to this question. X minus 3 is a factor. What does that mean? It means that 3 is a root. And if 3 is a root, then we should be able to substitute it into our function and get 0. So let's try that. So we're going to do f of 3. Okay. And we'll just show that works. We're going to get 2 times by 3 cubed. 3 cubed is 27. 2 times by 27 is 54. 3 squared is 9 times by 3 is 27. 8 times by 3 is 24, and then minus 3, and you see that gives you 0. Okay, so
we've shown there that yes, indeed, x minus 3 is a factor, which means that 3 is a root. Okay, but we're not actually asked to show that in the question. What we're asked to do is we're asked to solve the equation fully. Now, how can we do that? If this is a factor, x minus 3, and x plus 1 is a factor, then actually x minus 3 times by x plus 1 is also a factor, right? So in other words, we can write it as a quadratic factor, right? So x minus 3 times by x plus 1 is also going to be a factor of the entire function. So if we expand that, we're going to get x squared plus x minus 3x minus 3. So x squared minus 2x minus 3 is the quadratic. Okay, so let's just think about it. If that's a factor and that's a factor, then this quadratic is also a factor. In the same way that, let's say I've got, if I know that, let's say I've got the number 20, right? And I know that there are two factors of 20, or let's say I've got, how do I want to do it? Like 2 and 10 and 5 and 2, right? If I know that 5 and 2 are both factors of 20, then I also know actually that 10, which is 5 times by 2, is also a factor of 20, right? So in this case, if I know that x minus 3 and x plus 1 are factors, I also know that x minus 3 times x plus 1 is also a factor, right? That's the logic. Okay, how can I use that? Well, I can basically use it now by doing polynomial division. I'm going to take my entire polynomial and I'm going to divide it by this quadratic. So I have got the quadratic. What is it? 2x cubed minus 3x squared minus 8x minus 3x squared minus 8x minus 3. Okay, and I'm going to divide that whole thing by x squared minus 2x minus 3. Okay, like that. So I'm going to do polynomial division. How do I do polynomial division? Well, I take my leading term, which in this case is this thing here, 2x cubed, and I'm going to divide it by x squared. And if I do that, I'm going to get 2x. Okay, and then I take that 2x and I multiply it through by everything in the divisor. So 2x times by x squared is 2x cubed. 2x times by negative 2x is negative 4x squared. And 2x times by negative 3 is negative 6x. And so then what I'm going to do is I'm going to subtract the bottom equation from the top. So 2x cubed minus 2x cubed is 0. Negative 3x squared minus 4x squared. So I'm adding 4x squared. It's going to be plus x squared. Negative 8x minus 6x is negative 2x. And I'm left with the negative 3. And I take the leading term again, x squared. I divide it by x squared. I get 1. So I get plus 1 there. And I take that 1 and I multiply it through by the entire divisor. So 1 times by that will just be x squared minus 2x minus 3. And of course, if I was to subtract that off, again, then what I'll get is I'll get 0, right? Which is what we want, because we know that this thing here is a factor, so there shouldn't be any remainder. We should get a remainder of 0. So what has that showed? That has also showed that 2x plus 1 is also a factor of our polynomial. So the polynomial can be written as f of x is equal to, so the factors were x minus 3 and x plus 1. So x minus 3 and x plus 1 and 2x plus 1 is the remaining factor. And if that's the case, then what's going to be the roots of this function? In other words, where will f of x equal 0? Well, it will either be when x is equal to positive 3, or x is equal to negative 1, or x is equal to negative a half, right? When 2x plus 1 is equal to 0. So I get x is 3, x is negative 1, and x is negative a half will be the solutions there. Yeah, okay, that's the answers. So let's move on to the next part. Okay, the polynomial p of x is equal to this thing here, blah, 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 where a, b, and c are constants, has a remainder of negative 5 when divided by x minus 1, and the curve y equals p of x has stationary points at 4 upon 3 and 2. Find the values of a, b, and c. Okay, now then, here we've got to use the remainder theorem, right? So I stated the factor theorem in the first part, even though it wasn't really necessary. so now we're going to do the remainder theorem. What does the remainder theorem say? If we take a polynomial p of x and we divide it by x minus a, and we get a remainder r, then what that means is that if we were to substitute a into the polynomial, we will get the remainder r, right? So an example, if I was to take a polynomial and divide it by x minus 2, and I get a remainder of 5, that means if I was to take 2 and substitute it into the polynomial, I will get 5. Okay, so here in this particular case, we're dividing by x minus 1 and we get a remainder of negative 5. What does that actually mean? It means that if I was to take positive 1 and substitute it into the polynomial, I should get negative 5. So that's exactly what I'm going to do. So let's write that down. So we're saying negative 5 will equal to, if I substitute 1 in, I'm going to get 1 cubed, which is 1, plus a times by 1 squared, so that's a, plus b times by 1, which is b, plus c. Okay, and if I was to rearrange that, we're saying negative 6 is equal to a plus b plus c. So we've got an equation there. The second thing we're told is that the function has got stationary points when x is equal to 4 upon 3 and x is equal to 2. Well, how do we find stationary points? Stationary points is where the gradient is 0, and so that means it's where dy dx is 0. So we've got to differentiate this function here. So let's just write that all out. P of x is equal to x cubed plus ax squared plus bx plus c. Let me just double check all of that. Plus bx plus c, yeah. And we want to differentiate this, right? So we're going to find p prime. So if we differentiate that, we will get 3x squared plus 2ax plus b, right? If we differentiate bx, we get b, and if we differentiate c, we'll get 0, because c is a constant, okay? Now, if we have got stationary points at 4 upon 3 and 2, then what does that mean? It means the gradient of those two places is 0, so we know that p prime of 4 upon 3 is equal to 0, and p prime of 2 is also equal to 0. So what we're going to do is we're going to do that. So we'll substitute in 4 upon 3 into our first derivative, right? So into here. So we're going to get 3 times by 4 upon 3 all squared plus 2a times by 4 upon 3 plus b. So let's try to simplify that all out. So that's going to be 3 times by 4 squared, which is 16, divided by 3 squared, which is 9, plus 2a times by 4, which is 8a upon 3, plus b. Well, okay, we can cancel a little bit, right? Divide top and bottom by 3, so that gives us 16 upon 3. And I think the best thing is we get rid of the fraction. The way we get rid of the fraction is we multiply the entire equation through by 3. So if I do that, I'm going to get 16 plus 8a plus 3b. Okay? Or another way of writing that, probably better, is 8a plus 3b is equal to negative 16. 16. Okay? All right then. Well, we can do the same thing by substituting in x is equal to 2, isn't it, right? So we can say that p prime of 2 is also equal to 0, right? So if we do that, 0 will be equal to, okay, 3 times by 2 squared. So 2 squared is 4, plus 2a times by 2. So 2a times by 2 plus, what was it? Was it b? Plus b. All right, so that's going to be 12 plus 4a plus b. And so 4a plus b is going to be equal to negative 12. So what we've got here is we've got two equations, don't we? We've got equation 1 and we've got equation 2. So we've got two equations and two unknowns. Well, this is the same thing as simultaneous equations, isn't it? So the way I'm going to do this, I think I'll do it by elimination, right? I will multiply the second equation by 2, right? So I'm going to rewrite this guy. So 8a plus 4b is plus 3b is equal to negative 16. So 8a plus 3b is equal to negative 16. So that's the first equation. And then I'm going to take the second equation, I'm going to double it. So 8a plus 2b is equal to negative 24. And then I'm going to subtract 1 from the other, right? In order to get rid of the 8a. So I'm eliminating the 8a. So 8a minus 8a is 0. 3b minus 2b is just b. And negative 16 minus 24. So I'm adding 24 is going to be 8. So I get that, that b is equal to 8. Okay? And if I've got b is equal to 8, then I should be able to substitute in, right? So I know that 4a plus b is equal to negative 12. So we substitute in, so 4a plus b, which is 8, is equal to negative 12. So 4a is equal to negative 20. And so therefore a is going to be equal to negative 5. Okay, so I've got a is equal to negative 5. So now I need to go back and I need to find out what c is, right? Well, up here at the very top, we had that negative 6 is equal to a plus b plus c. So let's just substitute into here. So negative 6 is equal to a, which I think was negative 5, plus b, which was 8. Yeah, so b was equal to 8, plus c. So negative 6, negative 5 plus 8 is positive 3, plus c. So I get c is equal to negative 9. Okay, so I think that's our answers. Let me just double check that. Yep, c is equal to negative 9. Okay, I want to see if there's anything else in the question that we need to do. Just find the values a, b, and c. All right. Part 2. Hence, use the second derivative test to show that the stationary point at x is equal to 2 is a minimum. Okay, basically, what's the idea here, right? If the second derivative, if y double prime is positive, then what you have is you have a minimum. Whereas if y double prime is negative, then what you have is you have a maximum, right? That's the thing you basically need to know. And so we're just going to find the second derivative. So the first derivative was 3x squared plus 2ax plus b. So let's write that down. So y prime was 3x squared plus 2ax plus b. Yeah. And so we're going to differentiate it again. So y double prime is equal to 6x plus 2a. And we already know what the value of a is, right? A was equal to, let's just go down. What was it? Negative 5. So 2 times by negative 5 is negative 10. And so when x is equal to 2, we know that the second derivative, y double prime, is equal to 6 times by 2, which is 12, minus 10, which is equal to positive 2. And so you need to say something like, since y double prime is positive or is greater than 0, the stationary point is a minimum. Okay, and that'll be your answer.